Let's now try to answer question 10. So the smaller circles have radius 1. So that means that if I draw a line from the center of the big circle to one of the smaller circles, and if I consider this right angle triangle, it means that because the shorter sides are both 1, the radius of the smaller circle, that hypotenuse is √2. But if I extend that hypotenuse, so let me do it like this, the total length of that line, because this radius is 1, it means the total length of that line, which is the radius of the big circle, is 1 plus √2. Okay, so I've calculated the radius of the big circle, so I'm going to rub out my annotation so that I can now calculate the shaded area. So to do that, let's consider how to get the shaded area of this shape in the middle, which I've shaded red. And I can do that by considering this square, which I'll draw connecting the centers of the small circles. And the shaded area, which I'll just denote by the shaded lines, is going to equal the area of that square, which, because it's a 2 by 2 square, is 4, minus 4 of those quarter circles of radius 1. 4 quarter circles make a full circle of radius 1, pi r squared, r is 1, gives me that that shaded area is 4 minus pi. So I'm going to erase now the square that I drew. If I call the shaded area they're looking for A, then what I can say is that 4 of those A's plus the area I shaded, which is 4 minus pi, plus the 4 small circles, which have radius 1, of course, and so their area, each of them has area pi, so their total area is 4 pi, and that'll equal the area of the big circle, which is pi big R squared. So from that, I can solve for A. A is what I want. Substitute in R is 1 plus √2, and you can solve for A. So that's just a exercise in algebra, which I can leave you to do.